I'm Elijah Gutierrez, fifth-year electronics engineering student, De La Salipa.
I am Angelica Maricine Legaspi, fifth-year electronics engineering student from De La Salipa.
I am Denise Luis Basilio, a fifth-year engineering student from De La Salipa. Palm-vein technologies is one of the rising technologies in modern time. Palm veins has its own unique biometric features as a result for good properties in structure to have a high security pattern. It is highly secure due to the information contained within the body. These patterns are used to have a distinctive identification of a person's palm vein, which can be used for biomedical concerns and mostly in security systems. The advantages of the palm vein technology are it can be damaged and modified as an internal feature. Therefore, this kind of technology is more secured and much better to other biometrics like face and fingerprint recognition and to some traditional security systems like RFID. Identification and transaction systems have been at forefront of growing into electronic technology and allowing us to make digital development. Transactions are always paired with identity because it confirms personal details, authorizations, and entitlements that will help to enhance personal privacy and reduce fraud when transacting valuable items. One of the most used items in transaction and identification is the RFID card, but there are a couple of risks in using this as a key feature in identification and transaction. The risk involves the loss of control to personal data of the user. Profiling would be much easier, and this can be a cause of sharing the databases of the affiliates and can be used for unauthorized purposes. Thus, in order to address these problems, the proponents develop a system using palm vein technology wherein it can help an institution to have more secure transactions and identity classifications. For the objective part, here is Ms. Angelica Maris Legaspi.
Our study aims to design and develop a device will be using palm vein technology in order to cater bio-wallet and identification system, and here are the following objectives. The first objective is to design and develop 2 transaction devices and 2 registration devices. Registration device composed of different electronic devices such as Raspberry Pi camera module V2, 7 inches touchscreen display, and vein finder camera. Transaction device which composes 2 7 inches touchscreen display and vein finder camera.
The next objective is to perform data augmentation. Data augmentation is used to increase the number of data by rotating and cropping images in order to produce a larger dataset.
Next is to perform different image processing such as converting RGB images to grayscale images, resizing, and removing noise to enhance the gathered data.
Objective number 3 pertains to the feature extraction process of the system, which involves the local binary pattern and the histogram of oriented gradients. After the feature extraction, we are to perform the training process of the system. The training process involves 3 machine learning models, which are the support vector machine, k-nearest neighbor, and artificial neural network.
Another objective is to develop a cloud-based storage and website specifically designed for the storage of the student's detail such as name, section, and student number. Another one is to test and evaluate the efficiency and accuracy of the device and the whole system using a series of testing.
For the conceptual framework, we divided it into three parts, which are the user registration, data gathering and processing, and data retrieval. The user registration and data gathering pertains to the input part of the system. The inputs are student name, student section, student number, face image of the student, and palm-vein image of the student, which can be acquired using the data gathering tool. Consequently, the data processing part is where the image processing, feature extraction, and machine learning models training happen. The image processing involves resizing and RGB to grayscale, feature extraction involves HOG and LVP, while the machine learning models involves support vector machine, k-nearest neighbor, and artificial neural network. To further explain the conceptual diagram, here is Mr. Alejo Daniel Galiares.
Then I will discuss about the data retrieval, which the sent and stored data through the cloud is accessed by the website.
Our project's block diagram represents the different functions and fundamental blocks of input and outputs of the system. This is the combination of registration and transaction function of the system interconnected with a cloud-based storage. The process will start in registration device that will gather some data, such as capturing palm-vein images. These palm-vein images are used as the main data and train them using different machine learning models. This will make the system capable of identifying the list of persons registered in the system. Upon making some registration and transaction, this is stored in the cloud database, wherein the group will use PHP web hosting that they rented a local company at Livix Web Hosting. This cloud database will read and write the data over. This cloud storage will be responsible to run the system according to its function, as well as making some transaction and identifying the users. In hardware development, this is the physical development and construction of the design device, which is made up of metal sheet casing. First is the registration device. This is composed of different electronic devices embedded on the hardware casing, such as vein finder camera, Raspberry Pi B4, and the LCD display. Here are the dimensions of the physical hardware design, which consists of the isometric view, front view, and side view. Another is the transaction device, which composes more number of electronic components and devices. This has two holes for the 7-inch touchscreen display that is designed like a cashier-type device, which have two monitors for the user interface and stop interface. The following dimensions are also stated above, which are the isometric view, front view, and side view.
So for our software, programming is the primary part of the system since it will be the one responsible for controlling and execution of the hardware design towards the desired output. The website application will be used to display the student's information, device selection of transaction, and initial registration of the user. For the image acquisition, it will be done by interfacing the NIR camera with IR lights with the Raspberry Pi Model 4B microprocessor. For the image processing, we will be using the RGB to grayscale and resizing. Then it will be subjected to the feature extraction process, which is the combination of local binary pattern and histogram of oriented gradients. Our system will be using three machine learning algorithms such as k-nearest neighbor, artificial neural network, and SVM. Lastly, the data, adding and subtracting of e-money, will be done and stored using a database and will be sent wirelessly using a cloud-based system. For For this part, I will be discussing the different interpretations and evaluation of gathered data through the use of NOIR Vein Finder camera in the project study IVEINTITY. Different sets of testing trials for each subsystem are implemented in order to assess the functionality of a particular subsystem individually before assessing the whole system. To determine the functionality of each part, we place remarks such as successful or unsuccessful based on the stated incorrect or correct outputs. We first evaluated the functionality of the hardware devices. To evaluate the functionality of the hardware, we set 5 trials for each component. None of the hardwares malfunctioned during the evaluation, hence we proceeded to the development of the data gathering software. The data gathering device is composed of the Raspberry Pi connected to our laptop via router. We controlled the device with the aid of VNC Viewer, which enabled us to run the software on the Raspberry Pi. We did not encounter any problems with the software and hardware while gathering data, hence making it successful. The next is the development of the classifiers. For this part, we tried 3 different machine learning models in order to find the suitable model for our project. We find the models with different setups in order to find the optimal setup for each individual model. After the optimization, we obtained high accuracy training sets and was ready for interfacing. Other stages have gone through evaluation such as the image processing, which is the conversion of RGB to grayscale and resizing. Another one is the feature extraction, which is the HOG and LGP. Another one is the graphical user interface of the project. And lastly, the functionality of the project. All of them are deemed functional and successful.
Upon the development of the hardware device, which uses infrared technology to produce biometric authentication and also a smart transaction system that uses different electronic components and devices, the proponents found out that the Raspberry Pi NOIR camera is not compatible to the system due that it captures unclear images. So they find another camera, which is NOIR Vein Finder camera. Another is the touchscreen liquid crystal display that function as the monitoring device for both user and staff. And lastly, the Raspberry camera module V2 that is used in capturing face images of the user. Next, due to the limited number of data, the group has only 16 sets of actual images that does not reach their target dataset, which is 100 students. So, they perform data augmentation that includes rotating and cropping images in order to have a larger dataset. Another conclusion is the proponents accomplished the different image processing, including converting RGB images to grayscale images, and another is resizing the images. And this image processes obtained 100% that is accurate enough to proceed to the next processes.
Conclusion number 3 pertains to the feature extraction process. We performed local binary patterns and histogram-oriented gradients, and we successfully assessed the feature extraction using Python software. The output of the images fed to feature extractions are extracted in binary numbers and histogram that can be found in training data.csv. In line with the machine learning models, namely support vector machine, k-nearest neighbor, and artificial neural network, we utilize each models using Python and using scikit-learn library. The training of models were executed per section, and after the training, the proponents figure out that all the machine learning satisfy the 90% of condition.
Testing GUI that provide the registration of the student in order to have an account in the system, including the basic information needed, which are the name, student number, and student option. This also include the data to be used to identify them, which is the images of their palm vein pattern. We also created a website and a testing GUI to monitor the registration and transaction of the user. We also developed a testing GUI that also can be used as a registration and transaction. Both user and cashier have their own view of what is happening in real-time basis, whether the user will register or transact. The development of this website and testing GUI is less than 90% working because we don't have the actual device for transaction. In order to comply with the requirements, we use an alternative, including running the system of the testing GUI in our laptops, using the camera of the registration device as their main device for scanning the hand of the user. Upon the completion of implementing the whole project study, the proponents have difficulties upon the development of their projects due to limited data gathered that resulted in accuracy and efficiency of the project in less than 90%.
To fully improve the project study, we came up with certain recommendations. The first recommendation is to add some features to the transaction part of the device, like improving the cash-in system by making a transfer of money through mobile or bank transfer. Another is by notifying the user about their historical transactions. Additionally, we also recommend to make casing smaller than our original casing. The NOIR camera can also be changed into a better one. We also added to recommend to develop a mobile app for efficiency and an interactive display to make the system more friendly and easier to use.
The project testing shows the functionality of the whole system, which performs series of testing to test its efficiency and accuracy. The first GUI testing is the About GUI, which is an interface informing the user or staff about the importance of the project. Another GUI is the Developer GUI, which shows the researcher's profile together with their advisor. Once you click the Start button on the homepage GUI of the system, it will pop into another page which have a registration and transaction button. First click the registration button in order to create an account. The series of testing created 5 accounts to incorporate in the system. To test the system, first account is registered, which is the dummy account number 1, which includes the dummy name, dummy section and dummy student number in order to fill up the information needed for the account system. The next account is the dummy data number 2, which also includes name, section and student number to comply the information needed. The system will also gather palm vein images from the user as a data and train them with different training models to identify the user by his/her palm vein. Another series of testing is made by making an account for dummy data number 3. These dummy data does not have face identification, instead it is registered by the user palm images and then train the dummy dataset of the user's palm vein.
Another registered account is from a student named IVEINTITY, which also includes her section and student number. She is part of class T5B. Her actual palm vein images are registered in the system and trained by the different machine learning models to identify her as one of the person registered in the system. Her face identification is also included in the account. Next is another student from Lipa who is from class T5C. The student's name is Cheska Nicole Mercado. The student's information are also filled up and her face identification is seen on her profile.
The next testing of GUI is the transaction part. The transaction part is also divided into two portions. First one is making a transaction by buying a product and the other one is by reloading the balance on the student's account. First account to made transaction is or alloc ID. In this account, there are 4 series of testing. First is the right way to make a transaction, which the student will type his section first, then scan his hand and confirm it with the last 4 number of his student number, and when the interface success pop up, it means he successfully made a transaction. Next is the when the system scans a right palm but the user failed to type his or her student number correctly, then the system will pop an error message. Another is when the system scans a wrong palm, hence he typed the correct numbers, still the system will pop an error message. And lastly, when the system identifies that the balance on the account of the student has insufficient funds, it will pop up a message insufficient funds.
Next is transaction made by the user named Angelica Maris Legaspi, which is in class T5B. The series of testing is composed of 2 parts. First part is where the user input right section and right numbers of student number that made a successful transaction through the system. Another is the testing when there is an insufficient funds. Once the system detects that the account have insufficient funds, it will pop a message that states insufficient funds. Next is the account of Rico Panginiban that also included in class T5B. This is account also made 2 series of testing. First, he buys a product and upon making a transaction he type the class where he belongs and scan his hand and confirmed it by inputting the last 4 digits of his student number. Then another testing is made by knowing that the account has insufficient balance. The system will know that the account has not enough funds to proceed to a transaction. Another is the account of Kit Viller. The series of testing is composed of 2 parts. First part is where the user input right section and right numbers of student number that made a successful transaction through the system. Another is the testing when there is an insufficient funds. Once the system detects that the account have insufficient funds, it will pop a message that states insufficient funds. Lastly is the account of IVEINTITY that also included in Class T5B. This is account also made 2 series of testing. First, she buys a product and upon making a transaction she type the class where she belongs and scan her hand and confirm it by inputting the last 4 digits of her student number. And another testing is made by knowing that the account has insufficient balance. The system will know that the account has not enough funds to proceed to a transaction. The second part of the transaction is the cash-in part where the users reload the balance on their account. Once they made a transaction, the system will subtract the amount of their purchased products on the corresponding account that you made the transaction. This series of testing in transaction, reloading part is made up of 2 scenarios. First, an oral Al-Qaidi's account wherein the previous testing shows that he has an insufficient amount of money on his account. First is the success part where the amount of money he reload to his account is successfully loaded. To successfully enter an amount on someone's account. The user needs to classify his class section, then scan his hand, and to confirm that at his hand he will put the last 4 digits of his student number. Another is the failed attempt to reload an amount of money in his account where he was not recognized by the system by means of wrong class, wrong hand or wrong student number. Another one who made a reloading transaction in her account is Angelica Legaspi. The first part show the successful reloading of amount of money, and the next part is the failed attempt to reload her account. And lastly, the account of Rico Pandini Bandit also made a successful and failed series of testing and reloading his account. This shows that the system is capable to make a registration and transaction efficiently by means of the different processes the proponents have made. The system is capable to identify the wrongdoings upon transaction with a different series of testing made. Nevertheless, that the student's whole functionality system together with hardware device is not in its expected accuracy of at least 90% due that the proponents do not have the actual device. They made a way to test and show the efficiency of the flow of their project by showing the testing GUI of their system which have high accuracy in identifying the errors made.